A circle is the set of all points in the plane equidistant or equally distant from a fixed point called the center. I've got that labeled HK, that's that red dot. The distance from the center to any point on the circle is a length called the radius r, and any point on the circle is just the xy point. There's a pin through the center of the circle at HK, and this rope in yellow represents the radius of the circle. As long as I keep that very taut and always exactly the same length, I will trace out a circle, and the important points about the circle are the center and the radius. We know the distance from the point xy to the point hk by the distance formula is the square root of x minus h squared plus y minus k squared, and we know that distance is r, that's how we defined it. If we raise both sides to the squared power or to the power of 2, we get the standard equation of a circle whose center is hk and whose radius is r. And of course r has to be positive and greater than 0. If r equals 0, it's just a point. So that means the general form of the equation of a circle is x squared plus y squared plus ax plus by plus c equals 0. So notice we have the standard form of the equation of a circle, x minus h all squared plus y minus k all squared equals r squared. R must be positive, hk is the center and r is the radius. Or we have the general form, x squared plus y squared plus ax plus by plus c equals 0. In our example, write the standard form of the equation of a circle centered at the point 1, 2 with a radius of 4. So the standard form is x minus 1 all squared plus y minus 2 all squared, since 1, 2 represents our hk point, equals 4 squared, or 16. The next example asks us to write the general form of the equation of that same circle. So I'm going to multiply out. I have x squared minus 2x plus 1, that's this term right here, plus y squared minus 4y plus 4 equals 16. So that gives me x squared plus y squared minus 2x minus 4y. I'm going to have a plus 5 minus 16, so that's negative 11 equals 0. Here's the standard form and here's the general form. So here's a graph of the circle. It has a radius of 4 and it's centered at the point 1, 2. Example, write the standard form of the equation of a circle with the endpoints 2, 6 and negative 6, 0. So here's my point 2, 6 and here's my point negative 6, 0, and the line segment that connects them, halfway through that will be the center of the circle. The midpoint of the line is the center of the circle. We are going to need two formulas to complete this task. The midpoint formula, x1 plus x2 divided by 2, that's halfway between the x values, and y1 plus y2 divided by 2, halfway between the y values. And then the distance formula, the distance between the 2 points, that's the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So for the midpoint, which of course will be a point, we have x1, which is 2, plus x2, which is negative 6, all divided by 2. And then for the y point, we have y1, which is 6, plus 0, all divided by 2. So this point is going to be 2, subtract 6, negative 4, divided by 2. So that's negative 2. And the y point will be 6 divided by 2, which is 3. So this is the midpoint of my line, but it's also the center of the circle. If I want the radius, I want to find the distance between one of the points, let's say the point 2, 6, and the center of the circle, negative 2, 3, and that will give me the radius of the circle. So I'm going to change this to say radius. For convenience, I'll call the point negative 2, 3, x2, y2. It's not going to matter which points you decide to label x1, y1. So x2, negative 2 minus 2 all squared plus 3 subtract 6 all squared. So this is going to be negative 4 squared, which is 16, and negative 3 squared, which is 9. So that's the square root of 25, or 5. So the radius is r equals 5. So we have found that the midpoint of the point 2, 6 and negative 6, 0 is negative 2, 3, which is the center of the circle, and the radius is 5. So our circle is x minus negative 2, since that's the x value, plus y minus 3 squared equals 5 squared, or x plus 2 squared plus y minus 3 squared equals 5 squared. So here is the circle in question with a radius of 5, the 2 points, and the center, which is negative 2, 3. In this example, we're given the general equation of the circle and asked to write the standard form. We're going to have to complete the square twice, once for the x's and once for the y's. So I'm going to group all the x's together. X squared plus 4x. I'm going to leave a space to complete the square. And then I have y squared minus 6y. I'm going to leave a place to complete the square, and that I'm going to add 12 to both sides, so that equals 12. Now I'm going to complete the square for the x's. So I take 1/2 the coefficient of the x term and square it, so that is 2 squared, or 4. And for the y term, I take 1/2 the coefficient of the y term, that's negative 3. All squared, and that's 9. Now I'm going to write this in red so you don't miss this step out. So it's plus 4 here, and it's plus 9 here. Well, I can't just go around adding to one side only. I've got to do the same thing to the other side. So this is an exercise in completing the square to get the format that we want. It is not an exercise in completing the square and setting it equal to 0 and solving, which I sometimes see students do. So this is a perfect square. It's actually x plus 2 all squared. It's this 2 here. And then I have y minus 3 all squared. It's this negative 3 here. And that equals 12 plus 4, 16 plus 9, or 25. So it's actually the equation of the previous example. So in the center we have negative 2, positive 3. This is a radius of 5. I go from negative 2 to 3 here, so I'll link the 5, and this is my circle.